So let's go to the real talk. So I'm going to very briefly answer the following questions. The first question is why everything has to be done in such an indirect way in mathematics. So for other science, it's quite direct. If you want to design a spacecraft, you just do it. You just do some things direct to it. But for mathematicians, we make things so abstract. So actually, this is the second question. So the power of symbols and abstractions. Why, if we have a problem, before we do that, we make it more abstract, and then we write it down. Then we write the solution, the proof, the answer in a quite abstract way. Why we should do that? So this is the second question I try to answer. And the third question is, since, as I said in example, the math world and the real world. The math world is a completely free world. In that world, you can open infinite many checking accounts. So there's more freedom in the math world than in our real world. But since the math world is a free world, so how do mathematicians choose the problems? There are many, many problems, and what problems we are particularly interested into. So I want to try to answer this question. And also, I want to answer the question why we care about other sciences. For pure mathematics, theoretically, it has nothing to do with any other sciences. But why we still need to keep an eye on the development of other sciences like physics, like biology, and many others. And the number 5 questions is I want to answer is the use of computer. So of course, with the usage of computer, we can do research in a much more effective way. For example, I can talk to my collaborator over the distance, use Skype. I can send email to everybody in 1 minute. So the knowledge of mathematics is more effectively spread. But this is not what I'm going to talk today. What I'm going to talk today is how the usage of computer to help us to study pure math, in particular to prove conjectures. Okay, so it might be a good time for me to introduce my own field. So I'm a professor in mathematics. So my field is I study mathematics, and my field of specialization is something called differential geometry, which I'm going to explain it in a minute, why there's such a strange name, because geometry is, to many people, geometry is Euclidean geometry. It is a science of just computing the distance, computing the area, computing the volume, and why differential in front of geometry. And the subfield is complex geometry, which is more specialized. We study geometry over complex manifold. Probably I shouldn't say that. It's too technical word to say. Okay. So one particular project, and actually that's one of my major projects, is in the mathematical aspect of the so-called superstring theory. So I emphasize on the mathematical aspects because even though I have a little knowledge, I have a little knowledge on string theory, I really don't know the complete picture of the string theory in the physics aspect. So what is a string theory? String theory is a physics theory that's supposed to explain everything. So by string theories, that the whole universe, from stars to atoms, are made from tiny vibrating strings. Those strings are so tiny, so far that use the current technology is not possible, or it's too costly to see them. Okay? But the physicists believe they exist. And related to the superstring theory, there's something called mirror symmetry. So what is mirror symmetry? Let me try to explain it in a very brief way. So mirror symmetry, so it says that we have two universes which are quite different. But on these two universes, the so-called quantum field theory are identical, are the same. Okay? So I have to confess that I don't know what the quantum field theory is, but there's a physical theory that says it's a two complete world. There's something that should you can identify them. And so intuitively, it looks like a mirror. From one universe through that strange mirror, you go to the other universes, and there's something corresponds. There's some correspondence in physics theory. Okay. All right, so my knowledge in the physics part of string theory is no more than this New York Times best-selling book written by Brian Greene. So Brian Greene is a professor in physics and mathematics in Columbia University, where I was at that time. I was a postdoc in Columbia University, so I learned some string theory from him. So this is a very readable, very nice book, and I recommend to all of you who are interested in string theory. The title of the book is called The Elegant Universe.